let me share my page. I forgot to do that. All right, so we'll take a look at the homework from Tuesday first. So for homework, I gave you a sequence: 80, -40, 20, -10. And then I asked you a few questions on that. So the first thing I asked you was, what is the common ratio? Which, again, you're going to have to find the common ratio or difference, but this was geometric sequences, so the common ratio is what you're looking for. Okay. And remember, it's always you're dividing the later term by the previous term. All right, so we're going to set up -40 over 80. Or you can do 20 over -40. Or you can do -10 over 20. They're all going to get you the same thing. And that is our common ratio of -1/2 or -0.5. Okay, so for the first one, you have -0.5 or -1/2. And then that's how we keep multiplying. And we get lower and lower and lower and lower. So I want to know, what is the 10th term? All right, so that means we have to use our formula for geometric sequences for finding our terms. So that would be an equals a1 times r minus n minus 1, r to the power of n minus 1. So we are looking for the 10th term. So right now I'm just going to plug in the 10, so I still have a1, and I'm going to do r to the 9th, right? Because we do 10, that's what we're looking for, minus 1. So that would get us 9th there. All right, so let's plug in what we have. Our first term, a1, is 80. Our r, we just found, was -0.5 to the 9th. All right, and actually, I didn't ask you for this specifically, but from this, we can get the formula for any of them. Right, and this would be the general formula. For the nth term. Okay, again, I didn't ask you for that, but essentially that's what we did here. Right, and we would calculate this. So I'd be careful when you're doing this too, as well. I mentioned, I've seen a lot of mistakes in the past where you guys will multiply 80 times this and then raise it to the 9th, so don't do that. But here, make sure, if you're plugging this into the calculator, make sure you use the parentheses and do parentheses -0.5 close parentheses to the 9th power. If you forget to close the parentheses, it's just going to make your answer negative no matter what. Okay, in this case, we get some really, really tiny decimal that is actually negative. So I'll just write the few first digits, 0.00195, and then that keeps going on. Right, and then you just multiply those together times 80. And your 10th term is approximately -0.16. If you give me 2 decimal points, -0.16. Now, this wasn't terrible. You could have actually just kept dividing by -0.5. So 80 divided by -0.5. I'm sorry, times -0.5. And I'm just doing this to see if we can get 5, 6, 7, 10. A fraction value for this, because it might be a little easier doing fractions. And this would be, yeah, -5/16. I mean, if I don't specify or if you don't see a problem that specifies put this in fraction form or put this in whatever, then you can give me either answer, and that's fine. All right, so this was 1, this was 2. All right, then I asked you to find the sum of the first 10 terms. So S10. Again, just a quick reminder, S of n, I need a reminder on this actually, I always forget this one, is the first term times 1 minus r to the n over 1 minus r. So S10 is going to be A1, which we know is 80, our first term, times 1 minus negative 0.5 to the 10th over 1 minus negative 0.5. All right, so again, just be careful with your signs and your symbols. So this is going to get you some crazy, I'll have to calculate this. 1 minus negative 0.5 to the 10th. So it's almost 1. Negative 0.5 to the 10th will get us some really small decimal. So in the numerator, we're going to have 0.999023. I'll leave it at that. And then down here, this is going to get us 1.5. All right, so I do that first 1.999023 divided by 1.5 and multiply that by 80. And you're going to get a decimal here, right? Because you get a decimal for that. And we'll say 53.28. Right. So depending on how you rounded, your after decimal might be a little different. You might have 0.26 or 0.3. That's all right. That's fine. That's close enough. Right. And again, it just depends on how you round this upper the numerator for that part. All right. And then there was one more question. And that you had to find an infinite sum. All right, so 9 plus 6 plus 4 plus blah, 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 blah. What does that equal? Well, for the infinite sum, the only two things we need is the first term and the common ratio. All right, well, our first term is 9, and our ratio is going to be 6 over 9 or 4 over 6. Those are the only numbers we're given, but luckily they both reduce to 2/3. I forgot I don't need the n here because it's not that. So our sum is going to be 9 over 1 minus 2/3, which is 9 over 1/3. So if I added up all these numbers and it goes on infinitely, I'm going to get 27. So the answer to that one is 27. Any questions? Okay. So yesterday, because I was absent, I did give you guys a few videos to watch. And it kind of worked out nicely because the topic of mathematical induction is interesting. It's good to know because it's good for most things in real life, right? So just in case you didn't watch it, we're not going to spend too much time on it. But how do I put this? Induction is taking what we know and using the information that we can gather from that to predict future outcomes. All right, so we're taking a bunch of data, whatever it may be, and we're using that to say what's going to happen in the future. So, some basic things that we use induction for is like population, right? So if you want to know the population of humans or a species, you record what you have from the past up to the present, and then you use that information to predict the future. And it's a good concept to be aware of, because it's going to help you. Something like that, even though there's it's not just a math concept, right? It's a good way to tackle problems in real life, right? And it's kind of how we've always tackled problems, right? Write down what you know, what you want to find out, and then try to connect the dots. So I don't want to spend too much time on that. Maybe if we have some more time at the end of the year, we'll go back into mathematical induction. So if you did not get a chance to watch the videos, please do that. They're quick, it's Khan Academy. I think, the longest one was like 8 minutes, maybe. And the whole lesson, so if you look on the left side of the video, it gives you all the lessons in that section. There's also something called mathematical deduction, which is a little different. But it's a good watch, right? And it's not going to hurt you. It's only going to better your education, right? So again, I don't want to spend too much time on that. So if you have any questions, please go back and watch that. If you have any questions about the video, or there's just something you don't get, then you can ask me and I'll do my best. All right, but today we're going to move on to something called the binomial theorem. So first, what is a binomial? It's probably been a while since. Right, a binomial is just any mathematical expression with two terms. So when we factor a quadratic, we're breaking it up into two binomials, right? So, right, this is one binomial. And this would be another binomial. Now, it doesn't always have to involve numbers. You can just have x plus y, right? That's a binomial. So, way back when math was first being invented and discovered, or however you want to put it, they started noticing patterns with binomials, right? Well, our first one, and those patterns came from raising them to certain powers. So the first one, x plus y to the 0, well, that's just going to equal 1. And then we have x plus y to the first, well, that's going to give us what we have, x plus y. Then after that, okay, they noticed a few things that were happening. Now, you may also be noticing a few patterns as well. Let me just write this one, and then let's start talking about it. Oops, I messed up. I skipped one, son of a gun. This is supposed to be to the third. My apologies. So this should, oh man, I'm all over the place today. I apologize. Now you might be saying to yourself, Mr. Murray, how do you know all of these expansions without actually foiling them, right? Because that's what we would have to do. X plus y squared is x plus y times x plus y, right? X plus y to the fourth is this 4 times. But there is a few neat little tricks. I'm not just some kind of nerd that memorizes all these, but there's a few things that we can do to help us. Now, one of the things we can notice is that whatever our power is, well, I have one extra term than what the power is, right? So when the power is 1, I have 2 terms. When the power is 2, I have 3 terms. When the power is 3, I have 4 terms, so on and so forth. That goes on forever, right? That's one of the things. You also may notice the exponents of x and y's and how they behave, right? So, I mean, for the first 3, it's not, maybe not as apparent, but for these 2, you can definitely see, right, what happens with our x's. X to the third, x squared, x, no x. And kind of the opposite happens for the y. No y, y to the first, y squared, y to the third, right? So you notice this kind of descending trend with the exponents of x and an ascending trend or an increasing trend for the exponents of y. Okay. You may also notice some patterns happening with the coefficients, right? 1. Here we would have a 1 and a 1, and then 1, 2, 1, and then 1, 3, 3, 1, and then 1, 4, 6, 4, 1. Right? So there's a lot of these common things that are happening that, the mathematicians took notice to. So one of the things now let me say this. So one of the patterns that first came to people's mind was the what was going on with the coefficients, right? So the coefficient is the number in front of your variable. All right, so we're going to consider the expansion of x plus y to the n. And again, just like before, n just means it can be any whole number, right? So we're considering anything, any of the powers, right? It could be anything. So if we expand this, now this part I need help with. So you may notice, this is an n up here. So the first 2 parts, the first 2 terms are fairly simple. Well, the first one is just going to be whatever your first term is to whatever power you have it raised to, right? So x with a 3 there, that's just going to be x to the third. X with the fourth there is going to be 4. Your second term, well, your coefficient is going to be whatever your n is, right? So here we have a 3, there we have a 3. Here we have a 4, there we have a 4. And then we start to see the trend with the variables, right? We drop the power of x and we introduce y, right? Technically here, I can put a y to the 0, but we don't put that because it's just 1 and it's unneeded. But after a while, right, after our first few where it's pretty simple and straightforward, they came up with something called a combination. All right, and this is our big part here. So they found that any spot, any term in your binomial expansion follows this pattern. Now, I only have 4 minutes. Crap. This is a special formula. You may have seen it on your calculator. It pops up in the math section. And it involves what we learned last week with factorials. So what this tells us is that we can find the coefficient of any binomial term using this NCR. And usually that's how you'll hear me refer to it, NCR. You may also see it written as a parentheses and an N over R like this without any fraction. Okay, so these two are the same thing. NCR and this mean the same thing. All right, so we'll expand on this tomorrow. Let's say I wanted to do x plus y, I don't know, to the 10th. So each one of these, what's happening is my n is always going to be the same, and the r tells me what term I'm on. So the first one is going to be 10, 0, x10, y0. Then we're going to have 10, 1, x9, y1. And we're going to have 10, 2, x8, y2, and it'll continue like that. All right. So yeah, let me try to do. So let's calculate this. All right, 10, 2. So here we're going to use some of those tricks we learned for factorials. I don't need the parentheses there. So first we simplify. So this would give me 10 factorial over 8 factorial times 2 factorial. But remember, we can write this out. I need more. All right, so this is my 10 factorial top, all the numbers multiplying up to 10. And again, what's nice is it cancels out with most of 8 factorial. So I have 9 times 10 over 2. So that's 45. So the coefficient for this would be 45. Right? And with this, you can find the coefficient of any of your terms. Right? And you don't necessarily need to know the variable part, but we'll talk about that more tomorrow. All right, guys. Yeah. So we'll wrap this part up tomorrow. We'll do some practice. Yeah, I'm going to give you one problem tonight, and I just want you to calculate one of these. Okay, so I'm going to give you some numbers, and you're just going to use this formula. Right, so just know that. Right, and then we'll pick up where we left off tomorrow. All right, guys. Have a good day, and I'll see you all later.